Today's learning target is I can find the greatest common factor of two or more numbers. Today we're going to be taking a look at what's called the greatest common factor, or sometimes you'll see it abbreviated as GCF. Now if you look up greatest common factor in the glossary in the back of the book, it says the greatest of the common factors of two or more numbers. Okay? Another way to look at that is this. It's the biggest factor that's the same between two or more numbers. So let's see what that means here. So we have two numbers here. We have 4 and we have 8. Now the factors of 4. So what a factor is a number we can count by to get to a particular number. In this case, let's find the factors of 4. So numbers I could count by to get to 4 would be 1. Okay, it would be 2, I could count by 2s, 2, 4, and 4. So those are the factors of 4. Another way to think about it is what numbers could you multiply by another whole number to get to that number? I could take 1 times 4, or I could take 2 times 2. So factors of 8, okay, numbers I could multiply to get to 8, or numbers I could count by, would be 1 and 8. So those would be two numbers I could count by to get there. Let's see, 2 and 4. Those would be factors. And now I find the greatest, or the biggest, same factor, okay, or common factor. So 1s are common factors, 2s are common factors, 4s are common factor, but the greatest common factor would be 4. So our greatest common factor of those two numbers would be 4. Now, when our numbers get a little bigger, like they are here, we need to have a strategy that we're going to use to find the greatest common factor. To do that, we're going to use prime factorization just like we used in the last lesson. Okay? So I remember when I do my prime factorization, I'm looking for two numbers that I could multiply that would get to that 18 in this case. So 2 is prime. I'm going to circle that one, and I'm left with 9 and 2, or left with 9. That would be 3 times 3, and those are both prime. So now I write those prime factors down here, 2 times 3 times 3, and now I move on to the 48. So I know that 6 times 8 gives me 48. Neither of those are prime, so I can break both of those down. 6 becomes 2 times 3. Okay, those are both prime. I circle them. 8 would be 2 times 4. 2 is prime, I'll circle it. And 4 is 2 times 2, so I circle both of those. So my prime factors for 48 are 2 times 2 times 2 times 2 times 3. Now what I'm going to do is I'm going to look for common factors between these two sets of numbers here. Okay, so I have a 2 here, and I see that's a common factor. It matches up with one of the factors in the other number. So now what I do is I circle this, and I'm going to cross out the one it matches with. Okay, now I go to the next number, 3, and I see 3 matches with this 3 right here. So there again, now I'm going to circle that, meaning it's a common factor and it matches with that. And now I look at this 3 and I see, are there any more factors over here it can match with? Now I can't use this number because I've already crossed it out. I already matched that one with this. So my last step now is to take the factors that were common, or the ones that I circled, or that matched in both sets of numbers, and I just multiply those. So in this case, I'm taking 2 times 3, which is 6. So I know my greatest common factor for those two numbers is 6, which means 6, I can count by 6 to get to both 18 and to 48, and that's the biggest number I can count by, or the biggest factor to get to those two numbers. If I was asked to find the greatest common factor, or GCF, of 12, 24, and 60. So I did a factor tree for each of these numbers, and I've shown you how to do that, so I'm not going to walk you through that. But you can see, here's the prime factorization for each of those numbers. Now my next step is going to be just like I did in the last problem. I'm going to look for common factors between these 3 sets of numbers and circle them if I find one. So I start here with the 2 right here, and I see there's a 2 right here and a 2 right here. So I'm going to circle that one and cross out the one it matches with in the other 2. Now it has to match in both of them. So now I look at this 2, and I see there's a 2 right here it matches with, and a 2 right here it matches with, so I'll circle that one and cross out the ones that it match with the other ones. And now I notice there's a 3 here, there's a 3 here, and a 3 here, so I'll circle that one, cross out the one it matched with in both of the other numbers. Okay, now I'm left with a 2 right here, and I'm left with a 5 right here. But since those don't match in all of the other sets of numbers, these are the only 3 numbers that match. So now to find the greatest common factor, I just take 2 times 2 times 3. 2 times 2 gives me 4, times 3 gives me 12. So that would be my greatest common factor.